Levels of measurement. We're moving into a different area now where it's not just definitions, but they have pretty much specific uses throughout. You need to know the definitions of these, and part of your homework is going to be to be able to identify the different levels of measurement. First one up is nominal. A nominal scale is one in which numbers are used as labels. Also can be called qualitative. If you notice from part 1, you'll see the data is classified into the two, categorical and numerical. We're dealing in the categorical side of nominal and ordinal. Okay, first one up is nominal. Values are observations that can be assigned a code in the form of a number, whereas the numbers are simply labels. Labels such as male and female, race. When we put them into a statistic to run them for statistics, we turn them into numbers. So like male would be 1 and female would be 2. Also, it can be anything upper, middle, lower in terms of socioeconomic status and that. Nominally scale variables cannot be used to perform any statistical computations. So male and female, we could not add up males and females, but we could give them a number like 1 and 2. Ordinal scale. Okay, values, observations that can be ranked and put in order or have a rating scale attached. You can count in order but not measure. Ordinals like house numbers, swimming level. And you can see over here on the left hand side where, if for example we can assign rank 1, which is higher than rank 2, 2 which is higher than rank 3. Instead of rank 1, 2, and 3, we can use other numbers which preserve the order. This is because we're not sure of the distance. That's the real key. We're not sure of the distance. So I come in first, you come in second. It tells me a ranking order, but it doesn't tell me that you lost to me by a thousandth of a second. And this will be ordinal values. Ratio. The measurement can have a value of a 0 as well, which makes this type of measurement unlike any other type of measurement. Okay, if you look on the right here, the ratio value measures that has the same properties as the interval level, which is next, with one exception, an absolute 0 point. In other words, we can apply arithmetic operations to the numbers to the total amount measured from the absolute 0 point, not some arbitrary point. So in other words, it has a value of 0. Think of this: weight, age, percentage of vote would be 1. There is a actual 0. Interval level of measurement not only classifies but orders the measurements, but it also specifies that distances between each interval on the scale are equivalent along the scale from low to high. Example would be interval level of measurement could be the measurement of anxiety in the student between the score of 10 and 11 if this interval was the same as 40 and 41. Although they may be different ends of the spectrum, the amount between 10 and 11 is the same as 40 and 41. The incremental change is exactly the same between those two numbers. Now 40 could be a lot higher than 10 and 11, but when we're talking about the distance between the two numbers, I would call it one notch. Independent and dependent variables. This is going to be another worksheet that you're going to have for your homework, and it's important for you to understand what the difference between an independent and dependent variable are. An independent variable, sometimes called an experimental or predictor variable, is a variable that is being manipulated in an experiment. A dependent variable, sometimes called an outcome variable, is run against the independent variable. Okay, it is a variable that stands alone and isn't changed by the other variables you're trying to measure. This is an important point. When you're looking for that independent variable, it is not going to be changed. The dependent variable is something that changes. So it's real important if you put those two definitions, what is going to stay constant and what is going to be changed. Examples would be for an independent variable, someone's age might be an independent variable. Other factors of what you eat, how much you go to school, how much television you watch, aren't going to change the person's age. So the independent variable would be age, and what you're going to run it against. Let's say how much they go to school. So if you take 16, 17, 18 year olds that are in high school, and you're going to put them how much they're going to school or how much absenteeism there is in school, that is a dependent variable that you're running it against age, which is your independent variable. Dependent variable is what you measure in the experiment and what is affected during the experiment. Okay, dependent variable is a variable that changes in response to the independent variable, usually measured or recorded. Okay, some examples: takes time to evaporate, bounce height of a ball, distance traveled, change in the plant height. This is very important to remember. The independent variable influences the change in the dependent variable.